Let's draw the graph of y equals 3 cos bracket 2x take away pi over 4 plus 1. Let's get our axes drawn first of all. So we may need to have some negative values on the x-axis, so let's have this, have a slightly longer x-axis. Right, okay, and we'll label the x-axis x and y. We'll do that in a moment. Right, first of all, remember we should start with the principal axis, so we have a plus 1 at the end. That means y equals 1 is the principal axis, the middle of the wave. So let's say this is 1 here. Okay, we've got a middle of the wave here. Let me do anything. So this dotted line is going to be the middle of our wave. Okay, right, and the amplitude is 3. That means from the middle we're going to go 3 units up. So 2, 3, 4, that'll be here. This is where the top of the wave is going to be at 4. So 4. Okay, that's a gap of 3 from 1. Okay, that's a gap of 3 there. And then below, a gap of 3 would take us down to -2. So this is the bottom. So these are the barriers. So it's not going to go above this yellow line. So it's not going to go below this yellow line or above that top one at 4, but it's going to touch it. And let's write in some key values. Right, let's go with this being, let's say this being pi 0, that's pi over 2 here, and this is 2 pi, okay? And then this would be minus pi here. Right, this is going to be a slightly complicated one because we've got all the 4 letters kicking in here. We've got an A, which is sorted out, and the D, which is sorted out. But it's this bit here that's the really confusing bit, because we have a B, which is 2 now. So the period is 2 pi divided by 2. Okay, that's 2 pi divided by B, remember. That's going to give you pi. So it's compressed the graph by half. So the length of one wave now is going to be pi units. Actually, I really shouldn't have done that wave because it's a cosine wave, right? So the length of the cosine wave, one of them is going to be pi units long, okay? But it's going to complicate matters a little bit because we've also got a shift as well. Now that minus pi over 4, right, means, remember, it's going to move it to the right pi over 4. So when you subtract inside, it means it's going to do the opposite, it's going to move right pi over 4 units. So we've got these two things to consider really, a compression and a shift to the right. Now what I tend to do is this, before I begin drawing my sketch on this, I just remind myself of what the cosine wave originally looks like, and I remember the key points. So 0, when cos is 0, you get 1. Okay, so cos is 0 equals 1. And then pi over 2, you get 0. And let's say that's pi. And then pi, you get -1. 3 pi over 2, you get 0 again. And then pi, 2 pi, sorry, you get back to 1 again, right? So I remember these key points. There's pi over 2, that's pi, this is 3 pi, and then this last one is at 2 pi, right? This last one here. Okay, remember cos of 0 is 1. Now, that's a good point to start with. Cos of something, a cos of 0 is 1. And that's going to help us determine where we're going to start, really. Okay, so if you imagine this, okay, let me rub out all of this stuff here. Let me rub out these arrows, okay? And I've put this blue bracket in on purpose because imagine if this, inside this blue bracket, we got 0 in there, okay? If we got 0 in there, then we would have 3 times cos of, imagine that all came to nothing. So we'd have 3 times cos of 0 plus 1, okay? But what's cos of 0? Well, cos of 0, according to this graph, is 1. So we do 3 times 1, add 1, you get 4, right? So, and that makes sense. So our top of the graph is going to be at 4. But here's the thing. How can I get 0 inside that bracket here? How can I get this to be 0? Because that will tell me where my wave is going to start. Right, so how can I get 0 in there? So if I look at that bracket in a bit more detail, 2 bracket x take away pi over 4, I want that to equal 0. How can I get it to equal 0? Well, look at this x value. If I made that x value pi over 4, okay, if I made it pi over 4 take away pi over 4 would give me 0 in here. And then 2 lots of 0 is 0, so I've got my 0, right? So what that means is at pi over 4, well, where's pi over 4? Well, that's pi over 2. Pi over 4 is here. That's a quarter of pi. At quarter of pi, I'd get 0 inside this bracket. I'd get 0 here. And that means I'd get 4 coming out. So my wave is going to start here. Let me do it in red. It's going to start. This is the starting point. Okay, it's going to be starting here at pi over 4. Yeah, quarter of pi. That's done, because that's what makes that bracket 0. And then 3 lots of cos times 0 is 3, then add 1 makes 4. So it's going to start there at the top. Just like this wave started at the top when I put 0 in the cos function. Right, and now let's look at the period as well, because the period is pi, right? So what we said is once we've got the starting point, we know that the length of the wave is going to be pi. So if we start at pi over 4 and we add pi, well, what do we get? We get 5 pi over 4, right? So that's where it's going to end, because the length of the wave is going to be pi. So it's going to end at 5 pi over 4, which is this pi added another quarter. So it's going to end here at the top. Remember, it starts here and then it loops around and it goes back to the starting point at the top of the, well, think about it as the top of the roller coaster. So it's going to end here. Right, so it's going to start there, end there, and in the middle, smack bang in the middle, it's going to hit its lowest point. But let's try and figure out that end point, actually. Let's try and figure out that minimum point. Again, if we go back to this original function, cos of pi equals minus 1. Right, that's the middle. Actually, no, that's probably not the best place to look at, actually. Let's look at where this value here, because cos of pi over 2 gives us nothing, right? Cos of pi over 2 equals nothing. And let's go back to this thing. And let me rub out all this. Because what I'd like now here, inside this bit here, inside this bracket, I would like that to be pi over 2. Okay, I'd like it to be pi over 2 because I know cos pi over 2 equals 0. And then I'd have to do, if I get cos pi over 2 here, so I'll do 3 times cos pi over 2 plus 1. But cos pi over 2, according to this graph, is 0. And 3 times nothing is nothing. Add 1, I'd get 1. So I know somewhere I'm going to be on this purple line here. But when does this thing equal pi over 2? When does this equal pi over 2? So doing a little bit of algebra, okay, let's try and solve this equation. Let me draw out all these little specks here. Right, first of all, let's get rid of the 2 by halving both sides. So that x take away pi over 2 equals pi over a quarter. Okay, oh sorry, not pi over 2, is it? It's pi over 4 here. And it's, okay, pi over 4. Right, so just by halving the 2, dividing that by 2 gives me pi over 4, sorry, a quarter of pi. So then adding now pi over 4 to this, getting rid of this one here, I get pi over 4, add pi over 4, pi over 4, add pi over 4. But what's a quarter plus a quarter is a half, so I get pi over 2. Right, so x equals pi over 2. So if we actually go to this function, pi over 2, I'm going to be at 1. I'm going to be here, pi over 2, at 1. So, I mean, I'm going to start here. I'm going to end here. Now, if you think about it, remember these things are in chunks. So, here's a chunk, and then the same distance here, I end up my minimum point. So that means I'm going to be at 3 pi over 2. Sorry, 3 pi over 4. 3 quarters pi, I'm going to be here at this particular point. And then at pi, I'm going to be back at 0. Sorry, back to my principal axis, and then I'm going to end here at the top at 5 pi over 4. Right, so there you go. You've got the complete wave, and you can see it is starting here and ending here like we predicted. And if you look at it, halfway between those 2 points, which is here, we get the lowest point. Okay, like we predicted. And then at pi over 2, we get it to be 1. Okay, at pi over 2, we get it to be 1. So there's the key points, and then it repeats itself as well. So how many squares do I use here? 4 squares, so another 4 squares. It's going to be, and that's a distance of 1 square, so there's a distance of 1 square that side as well. So 1 square, and then 1 square in, and then another 1 square to get up, and then another 1 square there. So it's going to look like this. Now if we double check it on our kind of GeoGebra software, first of all, let's change the actual function to cos, because we're working to cos. So let's get that sorted first of all. Oops, didn't like that because I did it in capitals. Okay, so get rid of caps lock. Oops. Cos. Okay, change to cos. Right, now let's change our values. Okay, A, what was the amplitude? It was what was it? 3, wasn't it? 3. Right, let's change that to 3. 3. Okay. And the displacement was 1. Let's change that to 1. Move the bar by 1. Okay, there's 1. So there's our principal axis, and you can see it's already got a height of 4 and the lowest point of -2. Okay, now let's change B to 2, because that was the, and you can see it's starting to squash it already. And if you look at it, it's half the length of a wave. Right, but what we need to do now is change C to, okay, so it's going to be X, take away C, so what do we need to change C to? We need to change C to pi divided by 4. Pi divided by 4 is decimal 0.7, or what was it, 0.79 or something like that. This is already set up into going into blocks of quarter of pi anyway, so we just need to change 0.79. Okay, so it's going to do, okay, let's just double check we've got it. So there's a 3 cos bracket 2x take away 0.79 plus 1, and there you go. And if you look at it, where did we say it was going to start? Here's the peak. Remember, cos starts the peak. And if you look at it, that's a quarter of pi, pi over 2. So it starts there. Pi over 2, it goes to 1. And then halfway, so that same distance across from this to this, that's 3 pi over 4. You can see it goes down to -2, and then pi goes back to 1. And then 5 pi over 2 goes back to the top. Okay, one thing to remember with these particular things, these cos and sine graphs, is that these peaks and troughs, they're perfectly symmetrical. So when I worked out, when we worked out that this distance here, okay, let me do it in yellow, this distance, it went like this, then I automatically knew that, okay, if I did 1 square there, it's going to be 1 square along. That means it's going to be automatically 1 square down like this, and then 1 square back up and 1 square like this, because these peaks and troughs, they're all symmetrical. Okay, they're mirrors of each other. So I just mirrored it here, so you can use that to help speed the process up. So what you should do now is you should practice. This is probably the hardest thing hardest type of problem you'll ever get asked to do, really, this one here. So it's got all the 4 things kicking in, really. But what I'd like you to do is, if you want to practice this, use this bit of software, the GeoGebra file, to check your answers. Or you can use your calculator as well. But if you want to have a go at this, look at exercise 10F on page 254 in your textbooks, or it's edition 2 we're working from, edition 2, sorry, the second edition book. Okay, the second edition book. And it's got a load of questions on this, but this is one I made up, and it's the hardest type of problem.